A very good afternoon to all. In the course Engineering Materials and Metallurgy, we have a beautiful topic today, that is thermopolymers and thermosetting polymers. So hope you have studied in your lower classes in the uh, +1, +2. We will explore what is thermoplastics. So thermoplastics soften when heating and can be molded into required shapes when in this state. They are hardened again on cooling, but heating and cooling they can be softened and heated over again and again. So that is why we are able to recycle thermoplastics accordingly. And thermosetting plastics undergo a chemical change during molding and hardening, and therefore cannot be softened again by heating. So that is why it can be melted repeatedly. Thermoplastics, thermosets are once it is shaped, cannot be melted. So you can see a one-shot cycle here, which is heated, it softens and softens when it cooled, and it is permanently rigid, and it cannot be reheated to form any other product. So commodity thermoplastics, we have polyethylene, polystyrene, polypropylene, polyvinyl chloride, and styrene acrylonitrile. So these flows at elevated temperatures has a glass transition temperature, long polymer chains, and can be remelted and recycled. So these are all the normal polymers we use in our day-to-day life. We understood that this polyvinyl chloride is PVC pipe, all we are using for domestic fittings, transfer of liquid from the top storage in the houses to the bottommost part, and all the PVC pipes belongs to this commodity thermoplastics. So engineering thermoplastics are categorized as polycarbonate, acrylonitrile, butadiene, styrene, and polyamide. Engineered plastics account for 10% of all plastic usage, generally have high tensile strength and elongation than commodity plastics. So the differences between these two, thermoplastic and thermosetting plastics, it's about it has a long straight chain and carbon compounds. Thermosetting plastics have cross-linked compounds formed by addition polymerization, formed by condensation polymerization. Low strength compared to thermosets, more strength compared to thermoplastics. Can be processed again and again and cannot be processed again and again. This is a summary of this particular topic. So the example is polyethylene and for thermoplastic, and the example for thermosetting plastics is bakelite and epoxy. So the difference as well as the property difference is chemical resistance. Thermoplastics, some have good chemical resistance, but most can be dissolved or weakened by at least some chemical compounds, because chemical reactions provide more temperature that disintegrates the chains between the polymers. And thermosetting plastics better chemical resistance than any other thermoplastic. The dimensional stability, because they respond to heat, their dimensional stability is related to their service temperature and their glass transition temperature. Thermosetting plastics have excellent dimensional stability. That's why we use in cooker handles. And creep cold flow, again, although it can be improved by adding fillers and reinforcements, they are not as good as thermosets, and much better than thermoplastics creep properties. Molded in stresses, thermoplastic causes uneven cooling, part design, mold design, and thermosetting plastics relatively low stress, which yield less distortion. Coming to the properties again, toughness, coloration, clarity, shrinkage. So almost thermosetting is not tough, brittle unless reinforced, and coloration, easy colorable, and color is maintained. Limited options are there. That's why we always see black color in cooker plastics. Clarity, many clear polymers are available, very few options for clarity. and shrinkage varies by process in thermosets. And long-term properties no need to be estimated based on the short-term data, can be predicted based on the experimental data. Cost less expensive, but thermoset has produced more scrap which cannot be reprocessed. So thermoplastics less tool wear with the unreinforced polymers. Thermoset most prevalent mold wear and greater potential for mold damage. So most thermosets are filled. And this is the assessment for your particular topic. Kindly go through it. Thank you all.